Welcome to a lesson with Dr. Powell. Let's talk about how we can use L'Hopital's rule to find the limit of a sequence. Now, sequences are just like functions, so it behaves the same way. So this is just review of L'Hopital's rule, really. Notice that as n goes off to infinity because that's what happens when we take limits of sequences, and we'll go off to infinity here. That the top goes to infinity and the bottom goes to infinity. Now that is a form that we can use for L'Hopital's rule. This is an uncalculable form, meaning we don't know what it is. For instance, like if you have like 3x over 2x and take a limit as x goes to infinity, the top goes to infinity, the bottom goes to infinity, yet the limit is 3/2. Well, if we just change this to like 6x over 2x, the limit will actually be 3, even though the top goes to infinity, the bottom goes to infinity. It's undeterminable. There are many things that have an infinity over infinity that have various different limits. So we need some other way to rewrite this to something that has the same limit that doesn't give us a form that's non-calculable, but one that we can actually work with. And that's why we have a rule like L'Hopital's rule. L'Hopital's rule also works for forms such as 0 over 0. Okay, so let's just kind of review what would happen with this. So we think of this as just being a function, like x over 2 to the x, and we just simply take a limit and use L'Hopital's rule. L'Hopital's rule states that when we take this limit, and if we have a form such as infinity over infinity, then we can replace this limit with another one, and it'll still have the same result. Namely, the limit where we take the derivative of the top function and the derivative of the bottom function. So this is how we take the derivative of 2 to the x. It's natural log of the base times 2 to the x again. And so then we look at this limit. Is this limit a little better? Well, yes. The bottom right here will go to infinity, whereas the top just stays at a number. And if you have a number over something big, over infinity, that will go to 0. Hence, we've just seen that the limit of the sequence a sub n is equal to 0. Thanks for watching.